Namaste everyone. Now today we are going to discuss trigonometric functions of sum and difference of angles. What we are going to see, a very important topic, trigonometric function of sum and difference of angle. So before we start the topic, let us understand what we already know. So two formulas, one is cos of minus x is equals to cos x, and second sin of minus x is equals to minus sin x. These two formulas we have already discussed, so we are going to use these two formulas while deriving formulas for trigonometric functions of sum and difference of angle. So the first formula that we are going to discuss is cos of x plus y. Now cos of x plus y is cos x into cos y minus sin x into sin y. Okay. So to understand this formula, to derive this formula, let us use unit circle method. So I will draw a unit circle. This is a unit circle. Now in this unit circle, let us say this is origin. So I will draw x-axis and y-axis. Now I will draw an angle x with the positive direction of x-axis. So suppose this is our angle x. This is, if I go for negative, okay. So here let us consider this angle x, and with this I will draw one more angle. From here it is y. So this whole angle, it will become x plus y. And as we discussed in the coordinates of point, the coordinate of this point, say this is point P1. So coordinate of this point P1 will be 1, 0. This is a unit circle, radius is 1. This is say P2, coordinate of this point P2 will be cos of x, sin of x. This point, let us say this is point P3. Now coordinate of point P3 will be cos of x plus y, sin of x plus y, and I will take one more point, say here, which is at an angle of minus y. Okay, when I go clockwise, so this will be minus y, and let us take this as point P4. The coordinate of this point P4 will be cos of minus y, sin of minus y. So I have point P1, P2, P3 and point P4. Now let us join. I will join 2 points. So for that let us use some other color, okay, which is, I hope, visible. Okay, so I will join this point P1, P3. Let us join this point P1, P3 and join this point P2, P4. Okay. So P2, P4, when you draw on your notebook with paper and pen, you will get a little better presentation. Now, in this unit circle, you can see that triangle P1, say this is origin O, P1, O, P3, this triangle, and P2, O, P4, this triangle. These two triangles are congruent by side angle side criteria. You can see that two sides are radius, okay, in both the triangles, and the central angle is x plus y, and in triangle P1, O, P3, it is x plus y, and in triangle P2, O, P4, it is x plus y. So your central angle is same. So by side angle side, these two triangles are congruent. So what we get that triangle, I will say that here, triangle P1, O, P3 and triangle P2, O, P4, instead of and, I will use the congruent sign. Okay, I am not going to prove that they are congruent. We already understand in 9th standard we have all these concepts. So these two triangles are congruent by side angle side criteria. So when they are congruent by side angle side, their corresponding sides are going to be equal. So therefore we can say that P1, P3, the distance of P1, P3 will be equals to the distance of P2, P4. So P1, P3 is equals to P2, P4, or I can say that P1, P3 square, P1, P3, we will say that P1, P3 square will be equal to P2, P4 square. Okay. Why we have taken square term? We are going to use the distance formula for that. When we take square, it will be more convenient as square root will not be there. So using distance formula, this P1, P3 square. So P1 is here, P3 is here. P1, P3 square is, the formula is x2 minus x1 the whole square plus y2 minus y1 the whole square. So here I can say that it is cos of x plus y, cos of x plus y minus 1 the whole square plus sin of x plus y the whole square. I got this is P1, P3 the whole square. Now this is equal to P2, P4, we can write as cos x minus cos of minus y the whole square plus sin x minus sin of minus y the whole square. So therefore, now this left hand side is cos x plus y minus 1 the whole square. So a minus b the whole square is a square. So this is cos x plus y, cos square x plus y minus 2ab, so 2 times cos of x plus y plus 1 plus sin square of x plus y. So, is equals to, this is equals to, here on right hand side, let us first solve inside the bracket. It is cos x minus, this is cos y, because cos of minus y is cos y. So it is cos x minus cos y the whole square plus here it is sin x plus sin y. Now y plus sin, because sin of minus y is minus sin y, so minus minus will become plus. So therefore, now this left hand side we have cos square of x plus y plus sin square of x plus y. So cos square theta plus sin square theta is 1. So So I will replace this with 1 minus 2 times we have cos of x plus y plus I have 1. This is equals to, on right hand side we will expand, so we will get cos square x minus 2 times cos x into cos y plus cos square y plus sin square x plus 2 sin x into sin y plus sin square y. So therefore I will say that this 1 plus 1 is 2, it is 2 minus 2 times cos x plus y is equals to, now on right hand side we have cos square x plus sin square x, I will replace this with 1. Then this cos square y plus sin square y, this also I will replace by 1. And here I have minus 2 times cos x into cos y plus 2 times sin x into sin y. Now on left hand side we have 2, on right hand side we have 2, so 2 and 2 will cancel. So therefore I have minus cos of x plus y is equals to, here I have, now I will take minus 2 common, so in bracket I have cos x into cos y. Now I am taking minus sign common, so this plus will become minus, minus sin x sin y. Again this minus sign I will cancel, here 2 is there, so this 2 will also cancel. So therefore finally what we get? We get cos of x plus y is equals to cos x into cos y minus sin x into sin y. So this is the result of cos x plus y. Now let us verify it with some known angle. So verify. What we do? We will take x as 30 degree and y as 60 degree. So my LHS is cos 90 degree and the value of cos 90 degree is 0. RHS is cos x, that is cos 30 into cos 60 minus sin 30 into sin 60. Now cos 30 is cos 30 degree. Cos 30 degree is root 3 by 2 into cos 60 is 1 by 2 minus sin 30 is 1 by 2 into sin 60 is root 3 by 2. Okay, I think it is not visible, now it is visible. So here this part and this part, they are root 3 divided by 4, root 3 divided by 4, so it is 0. So your LHS and RHS is equal. So you have verified it also. Okay, so finally you can say that, okay, we have derived one formula, that is cos of x plus y is equals to cos x into cos y minus sin x into sin y. And to derive this formula, this unit circle was helpful, right? So again let us see what we have done. We have taken one unit circle and that we have marked one point at an angle x, then from that we have taken another point at an angle y, so this total angle will become x plus y. Then we have taken one more point which is at an angle of minus y. So with the help of unit circle which we have discussed previously, we can mark the coordinate of point P1, P2, P3, P4. And from your understanding of congruence of triangle, we understand that triangle P1O P3 and P2O P4, they are congruent triangles. As the triangles are congruent, their corresponding sides are equal. So we have P1, P3 equal to P2, P4. Then using distance formula, we put their respective values, used some trigonometry, and we got the expression for cos x plus y as cos x cos y minus sin x sin y. So now this is very important formula, and using this formula only we are going to derive other formulas. So this is one derivation which you should know, and based on this we can find all other ratios. So let us see other ratios. Now when we replace y with minus y, okay, so we will take y as minus y. So what I will get? I will get cos of x minus y, and on this side it will be cos x cos of minus y minus sin x sin of minus y. Now cos x cos of minus y is cos y. Sin of minus y is minus sin y. So this minus minus it will become plus, and here I have sin x into sin y. So we have cos x cos y plus sin x sin y. So this is another formula. Cos of x minus y is cos x into cos y plus sin x into sin y. Now let us replace this x with 90 degree and y with x. So take x is equals to pi by 2 and y is equals to x. So this left hand side will become cos of pi by 2 minus x. Now this cos of pi by 2 minus x, here it is cos of pi divided by 2 into cos x. Now I am using this x as pi by 2 and this y as x. So here also I will replace this x with pi by 2, this y with x, and now I have plus sin pi by 2 into sin x. So this is equals to, now cos 90 degree. Cos 90 degree is sin 90 degree is 1, cos 90 degree is 0. So this whole term will become 0, and plus I have sin 90 as 1 into sin x. So what I got? I got the value of cos of 90 minus x as sin x. So cos 90 minus x is equals to sin x. Actually this formula you have learned in your 10th standard also, but see how we have derived this formula here. You have another method to derive this formula in your 10th standard, right? Okay. So cos of pi by 2 minus x is equals to sin x. Now what I will do? This x I will replace by pi by 2 minus x. So when I say x is equals to pi by 2 minus x, so here cos pi by 2 minus this x is replaced by pi by 2 minus x, and on right hand side I have sin of pi by 2 minus x. So we are going to find the formula for sin pi by 2 minus x. Now here on left hand side we get cos of, now when I open the bracket I will get cos of x, pi by 2 will cancel, and minus minus it will be plus. So cos x is equals to sin of pi by 2 minus x. So cos x is sin pi by 2 minus x. Sin x is cos pi by 2 minus x. So sin 90 minus theta is cos theta, cos 90 minus theta is sin theta. So these two formulas also we have done, okay, in 10th standard. Now using this I am going to find sin x plus y, sin x minus y. So cos pi by 2 minus x is sin x. So what I will do, I will replace this x with x plus y. So I am going to use this formula, cos of pi by 2 minus x is equals to sin x. Now here what I will do, I will say ki put this x as x plus y. So what I will get? I will get cos of, now this is pi by 2 minus, in bracket I have x plus y, and this will become sin of x plus y. So the value of sin x plus y, sin of x plus y we can find out, okay, by using this expansion. Now here I will open the bracket. How I will open the bracket? I will write this as cos. Now it will be pi by 2 minus x minus y. Now this pi by 2 minus x I will club. So after expansion, now cos a minus b formula I can use. Cos a minus b is cos a cos b plus sin a sin b. So here I can say that this is cos pi by 2 minus x cos a cos b plus sin a into sin b is equals to, on right hand side I have sin of x plus y. If you feel that you are getting confused, so then you can take a pause here. You can again revise formula from beginning and then proceed. Okay. Now cos of 90 minus theta, cos 90 minus theta is sin theta. So this will become sin x into cos y, sin x into cos y plus sin 90 minus theta is cos theta, so it is cos x into sin y, and on right hand side I have sin of x plus y. So therefore finally I can say that sin of x plus y is equals to sin x into cos y plus cos x into sin y. Now when I replace this y with minus y, put y is equals to minus y, so I will get sin of x minus y. Now I am not going in that detail. I will have sin x into cos. Now cos of minus y I should write, but cos of minus y we know that it is cos y only. So I write sin x cos y plus cos x into sin minus y is minus sin y. So directly I say it is minus cos x into sin y. So we have seen formulas of, let us put together what different formulas we have discussed. So here first we understand, we have started with this cos of minus x is equals to cos x. Okay, this we have already seen using unit circle. I am not discussing it. Then we have sin of minus x as sin of minus x as minus sin x. Okay, these are two important formulas that we are going to use, okay, in future. Now we have derived cos of x plus y. So cos of x plus y we got cos x into cos y minus sin x into sin y. Then we find the formula of cos of x minus y. The formula for cos x minus y is cos x into cos y plus it is sin x into sin y. So this is cos x plus y, this is cos x minus y. Then we have sin x plus y, sin x plus y as sin x into cos y plus cos x into sin y. You can see that when we have formula for cos, both the cos terms are together and both the sin terms are together. And one more thing, that when we use plus sign here we are getting minus sign, and when we are using minus sign we are getting plus sign. But in case of sin, when it is plus sign, I am getting plus sign over here, and we are seeing that ki sin and cos both the terms are coming together. Okay, in each term we are getting sin and cos. So sin x plus y is sin x cos y plus cos x sin y, and sin of x minus y will be sin x into cos y minus cos x into sin y. This is sin x minus y. We have also seen that sin of 90 minus x is equals to cos x, and cos of 90 minus x as sin x. Okay, so now we are in position to see few more formulas related with this 90-degree angle using this. Okay, so sin 90 minus x is cos x. Now what about sin 90 plus x? So if I put x is equals to minus x, okay, so then I get the formula for sin pi by 2 plus x, and here I will get cos of minus x, which is cos x. So sin 90 plus x is cos x, and cos of 90 plus x, I get sin of minus x, which is minus sin x. Okay, so in case x is an acute angle, this sin 90 plus x indicates I am in second quadrant, and when I am in second quadrant, the value of sin of angle, that is y coordinate, okay, is positive. So here I am getting a positive result. And in second quadrant, the value of cos, for that we have to see x coordinate. As x coordinate is negative, we are getting here a negative value. So sin 90 plus x is cos x, cos 90 plus x is minus sin x. Two more, means if you are observing carefully, one more observation is there, that whenever we are using 90 degree, okay, we are using 90 degree with x, our sign is changing to cos, cos is changing to sin. Now let us see what happened when we replace this 90 degree with 180 degree. So for that, what we will do, this x, okay, this x I will replace with pi by 2 plus x. Right now, this x we will replace by pi by 2 plus x. So let us do sin of, now I will say that put x is equals to pi by 2 plus x. So then I have sin of pi by 2 plus x, that will give me sin pi plus x. So sin pi plus x will become cos of pi by 2 plus x, and cos of pi by 2 plus x is minus sin x. Okay, so sin of pi plus x is minus sin x. Similarly, cos of pi plus x, so cos pi plus x, here I am replacing this x with pi by 2 plus x, so I will get sin of, actually this is minus sin x, na? So minus, I will use minus sign here, minus sin, now x is replaced by pi by 2 plus x. Now sin pi by 2 plus x is cos x, so this is minus of cos x. Okay, so sin pi by 2 plus x is minus sin x, cos pi by 2 sin pi plus x is minus sin x, and cos pi plus x is minus cos x. So if x is acute angle, then pi plus x indicates third quadrant, and we know that in third quadrant sin and cos both are negative, and here we are getting the negative result. Sin pi plus x is minus sin x, cos pi plus x as minus cos x. In the same way, we can find values for angle when this pi is replaced by 2 pi, or right, what we do, this x we replace by pi plus x, and then we can have sin of 2 pi plus x. Sin of 2 pi plus x, we will get sin x, cos of 2 pi plus x, we will get cos x, and sin of 2 pi minus x, we will get sin of minus x, which is minus sin x, and cos of 2 pi minus x, okay, what I will do, okay, fine. So cos of 2 pi minus x will be cos of minus x, and the value of cos of minus x is minus cos x. When we are dealing with 2 pi, okay, 2 pi is 360 degree, 360 degree is a complete circle. So we are again reaching at the same point. So this 2 pi or any multiple of 2 pi we can ignore and directly take the angle which is along with 2 pi. So sin of 2 pi minus x is minus sin x, cos of 2 pi minus x is minus cos x, sin of 2 pi plus x is sin x, cos of 2 pi plus x is cos x. So whenever our calculation is with pi or 2 pi, okay, our ratio is not changing, means the sin remains sin, cos remains cos, only we have to see their sign. And for their sign, we can use the coordinate system. Okay, we have seen that in first coordinate all ratios are positive, in second coordinate sin is positive, so cosec is also positive. In third quadrant we have sin and cos both negative, only tan is positive, so cot is also positive. And in fourth quadrant we have cos positive, and as cos is positive, sec is also positive. So using this I can write for all the trigonometric ratios. Now one more thing we have understood, that whenever angle is pi by 2, our sin is changing to cos, cos is changing to sin. Okay, so whenever it is pi by 2, or I will extend it to 3 pi by 2 or 5 pi by 2, okay, or 7 pi by 2, in all cases our trigonometric ratio sin will change to cos, cos will change to sin. And whenever we are dealing with pi, 2 pi, 3 pi, 4 pi and so on, then in that case our trigonometric ratios will remain same, only we have to think for their sign. I will discuss all these things again once again, okay, here in light what I am discussing. So let us first say for 90 degree, okay, odd multiple of 90 degree, I will say that odd multiple of 90 degree. So pi by 2, okay, plus x. Now this is 1 into pi by 2. So 1 into pi by 2, I say that my ratio will change, so sin will change in cos. So it will become cos of x. Now whether it is plus or minus, so that depends in which quadrant this angle is, and for that we take x as an acute angle. So this is second quadrant, and in second quadrant the sin function is positive, so I will say that okay, this is positive, this is cos x. Okay, when I say sin of pi by 2 minus x, then also I will write cos x, and now again I will see in which quadrant it is. So if x is acute angle, then this is in first quadrant, and in first quadrant all the ratios are positive, so this sign is positive, so therefore here it will be cos x only. Okay. Now if I discuss for cos, when I say cos pi by 2 plus x, so I will say that okay, this will change to sign. Now regarding their sign, in second quadrant cos is negative, so I will use minus sign, and cos of pi by 2 minus x, it is first quadrant, and in first quadrant cos is positive, so it is sin x. Simple. Okay. Now let us see what happened if I take 3 pi by 2 plus x. So I will replace it is sine of now 3 pi by 2 plus x. So when I say 3 pi by 2 plus x, I am in fourth quadrant. My ratio will change from sine to cos. Regarding their sign, in fourth quadrant, sine is negative, so I will use minus sign here. Then cos of 3 pi by 2 plus x, I will say that it is sin x, and regarding their sign, so cos in fourth quadrant is positive, so this is sin x only. Sine of 3 pi by 2 minus x, this is third quadrant, and in third quadrant the value of sine is negative, so I have minus sign, and this sign will change to cos, so minus cos x, and cos of 3 pi by 2 minus x, again third quadrant, so cos is also negative, so I have minus sin x. Okay. So I think you are clear that whenever we are dealing with odd multiples of pi by 2, that is pi by 2, 3 pi by 2, 5 pi by 2 and so on, our ratio sign changes to cos, cos changes to sin. Now I am discussing for sin and cos. What about tan, cot, sec, cosec? So as it is for sin cos, the same thing is applicable for tan cot. Tan will change to cot, cot will change to tan, sec will change to cosec, cosec will change to sec. Right? Okay. And whenever we have angle as even multiple of pi by 2, even multiple of pi by 2 means sin pi, sin 2 pi, sin 3 pi, like that. So for that my ratios are not changing, means when I am saying sin pi plus x, so it is sin x. Now only I have to see which quadrant this angle is. So this is in third quadrant, so I will say minus sin x, and cos of pi plus x, this is minus cos x. Okay. So my ratio remains same, sin will remain sin, cos will remain cos. When I say sin of pi minus x, so I am in second quadrant, in second quadrant sin is positive, so I have sin x. Cos pi minus x, in second quadrant cos is negative, so I have minus cos x. And in the same way I can do for 2 pi. Okay. So we have seen, okay, we have seen what we have seen. We have seen, we can say that all ratios of subtraction and additions. So we have seen the formulas for addition and subtraction of the angles. Okay. So I will stop my lecture here. You have to revise this lecture again. You should be in position to find all these angles by yourself. Okay. Then and then only I recommend that go further. Right. So thank you for being with me in this lecture, and next lecture we will see few more formulas. Thank you.